Hello everyone and welcome to Robotics 101 by Dream School. So, in this course, we're going to learn about robotic systems. How do they work? How you can make one. Okay? So, first of all, we'd like to start by introducing ourselves. So, who are we? I'll be your instructor. I'm Mahdi Hassan. I've completed my bachelor's in Electrical and Electronics Engineering from Queen Mary, University of London. I've been working in the robotics sector for more than 3 years. I was a president of Queen Mary AI and Robotics Society. I've had a passion for robotics, artificial intelligence, and business for a long time. Let's start. So, who is this class for? Anyone who is extremely passionate about robotics. Anyone who is doing robotics engineering. Anyone who wants to design and build advanced robots. This course is not for anyone who's just looking to go through some videos and not do the work. You have to put in the work if you actually want to get the result out of this course. So, what are the prerequisites? First of all, you need the knowledge of basic mathematics. You need the knowledge of computing. You need the knowledge of electronics, engineering principles, and you need access to computer, electronic parts, and design software. We'll tell you all about them later on. Let's look at some of the robots of today. As you can see on the screen, this is Asimo Robot by Honda. This is one of the most advanced robots in the world right now. Then we'll look at some of the robots by Boston Dynamics, Pepper Robot by SoftBank Robotics, Industrial Robots by ABB, and KUKA. So, as you can see on the slide, these are some of the robots by Boston Dynamics. These are quite advanced robots of our time. So, here we have Atlas and many of the other versions designed by Boston Dynamics. You might have already seen the videos on YouTube online. They're quite advanced and these robots can do stunts. They can rotate, they can jump, they can run in complicated terrains. Then we have the Pepper Robot. This is one of the kind of advanced humanoid robots of today. You would see these robots in Japan. They're using it for research purpose right now. It can socialize, it can talk, it can move around. It can rotate its hand. It can shake your hand. Currently, they're using this robot in schools and universities for research and learning purposes. This robot is also used for talking with the old people. Next up on the screen, you can see the Industrial Robots by KUKA. These robots can move swiftly in many directions. As you can see here on the screen, this is the base of the robot. Then this part is known as the joint. Then this part is connected through this, and it has a joint over here as well. And then there is another joint over here and another here. So this robot can move in many directions, in many parts, okay? So this has a lot of degree of freedoms. It's one of the advanced industrial robots. And it's quite powerful. It can lift many heavy objects as well. So, what we will learn over this course. First of all, we're going to go through linear algebra, engineering mathematics, rigid body mechanics, control systems theory, differential geometry, robotics theory, robot modeling, robot planning and control. We'll also learn about the electronics, the components that are required to make robots. Then We'll give you an idea about the concept of kinematics, inverse kinematics, about the movement, how robots are moving their hands from one position to the other. We're going to learn about sensors and actuators, how the robot is going to sense from the environment, how is it going to process it and actuate accordingly. Then we're going to learn about robot manipulators. We're also going to learn about trajectory and motion planning. So for example, your robot is around here. This wants to go somewhere else. So what would it need? It would need to plan the whole process, right? There are countless ways it can go from point A to point B in many ways. Did you get it? Then we're going to learn about the design and build process. We're going to learn about the control architecture and how robots see, what it interprets through the cameras. This field is known as computer vision. And then we're going to learn about robot operating system, known as ROS. It's an open source system. You can use it to program and maintain and control your robot. Then we'll learn to program some robots at the end of this course. So let me give you a quick idea about what we're going to learn in this section. In the first section, we're going to learn about linear algebra, engineering mathematics, okay? So if you want to work with robots, you have to know the basics of position system, linear algebra, from how we're going to determine when the robot moves from one place to the other place. We need a mathematical model for that. And to understand those things, we need engineering mathematics. This is basically the basic form of maths. Then we're going to learn about rigid body mechanics. That means the position system, the movement, the dynamics, and everything about a rigid body. Then we're going to learn about control systems. What are they? How do you know about systems moving from one place to the other? How do you control them? And everything in there. Then we're going to learn about differential geometry. Next, we're going to learn the basics of robotics, the definition, the application, the modeling, then planning, control, electronics, and components involved. Then we're going to go through kinematics, differential kinematics, statics. Okay, it's about the movement from one place to the other, the rotation and everything together, and what happens when the robot moves from the other in a different angle. So all these we're going to learn it in this sector. Then we're going to learn about trajectory planning, path and trajectory. We're going to learn about joint space trajectories. So as you can see, the robot over here, there's a joint here, there's a joint here, and here. So this robot can move in many directions. Then we're going to learn about operational space trajectories. After that, we're going to go through actuators and sensors, how robots can sense and actuate. We're going to learn about joints, different drives, different kind of sensors. Then we're going to move on to the programming bit. We're going to learn how to program robots, how robot operating system works, how to plan the movement, and understand simulations. Then we're going to go through computer vision, understand and interpret the camera, whatever robot sees. Then we're going to learn about vision control, OpenCV, and different algorithms. So, what are the study method for this course? First of all, you have to follow through the lessons. Then you have to go through the resources, then revisit the lessons, take short breaks when learning, when going through the sessions. You have to commit at least 2 hours per week. You have to finish the problem sets that we give you in the lecture. You have to participate in the forum. You have to ask questions there and help other people out. Thank you. This is our website, www.dreamschool.xyz, you can find ebooks and other courses here. Thank you for watching. Have a great day.